All right, first thing we want to review is what we did last time. I realize a weekend happened in there for you guys, but what we did with the rest of this here is a big in-depth conversation about what quadrants these inverse functions end up in. What quadrants are the odd ones in? If it's odd, what two? Because it's only two quadrants that are options. Like it's very restricted. Good, 1 and 4. And the even ones, perfect. We spent a whole block just going over that. Just what quadrants are you going to end up in? So the even ones are in 1 and 2. Which ones are the even ones? Because there's only 2 even ones. Cosine and secant, good. Secant and cosine are the only 2 even ones. All the rest are in 1 and 4. Also, there's 2 different ways you can write inverse. You can write it with that little -1. That's how it looks on your calculator, but you can also write arc. It literally means the exact same thing. Don't let that stress you out. Both of these mean inverse. It's just inverse trig, all right? Arc sine or sine inverse with a little -1, okay? 1/2 is positive. That means it's going to be in quadrant 1. So draw yourself a triangle in quadrant 1. If it's positive, it's going to be in quadrant 1. If it's negative, it'll be in whatever the other option is, whether it's 2 or 4. But if it's positive, it has to be in quadrant 1. All right, sine is the y value. So the 1/2 has to go here, because that's where the y value would be. What angle would go across from the 1/2? Pi/6, and that's your answer. Your goal is to get the amount of rotation that you went. If you're in quadrant 1, that just is your answer. If you're sitting there going, that's it, yep, but you have to be able to do them forwards in order to be able to do them backwards. Does this make sense? And you have to know what quadrants you're restricted to. All right, let's try another one. Sine inverse of -1. That's going to be a circle, not a triangle. You need a place on the unit circle, and give me a word like up, down, left, or right, where sine is -1 and sine's the y value. So would that be up, down, left, or right? Down, good. So it would be right here. Now here is the thing. Sine inverse is either in quadrant 1 or 4. Those 2 quadrants don't exist. And a lot of times I'll just tell people to X out the ones that aren't there. You can't rotate through them. So you can't start here and rotate this way to get down there when these quadrants don't exist. It's like you have a building, but the second story is missing. If the second story is missing, you can't have a third story. Does this make sense? Like it's just totally not there. It's like a void. So how do we get to this point if we can't rotate through these quadrants? You have to go backwards. Good. So your answer will be negative what? Half a pi. Good. -pi/2. And again, if you look back at the range for inverse sine, it's right here, -pi/2 to +pi/2. That's what we looked at last time. All right, sine inverse of -2. You're not going to be able to do that. I threw that on here just for us to have a conversation about this. Your sine wave bounces between what 2 values? Like if you think about your sine wave like this, what is your high point and your low point? Yeah, it goes up to 1 and down to -1. So it can't get to -2. So you can't get an answer for that. It's like a no solution kind of thing. All right, arc cosine of 1. Cosine is the x value. So using a word like up, down, left, or right, where on our unit circle will our x value be 1? Right, good. And your goal is the amount of rotation. That's what your answer should be, is the amount of rotation. So what's the amount of rotation right there? 0. 0 pi, nothing pi. All right, this one is cosine inverse, and it's negative. So again, what are the 2 quadrants that are options for cosine inverse? What are the 2 options that we're restricted to? 1 or 2. Since it's negative, it's going to have to be in quadrant 2. If it's positive, it'll be in 1. If it's negative, it's wherever the other option is. Cosine is the x value, so that goes right here, that -√2/2. What does that mean the other side is? √2/2. And what does that mean the angle is? Pi/4. Now here's where it's a little tricky because we're not in quadrant 1. Your goal is the amount of rotation that it took to get there. So how much did we rotate to get there into quadrant 2? That angle is pi, that reference angle is pi/4. Good, 3 pi/4 is our answer. So just remember, your goal is the amount that you rotate. This one is pretty tricky because when you see a 1, don't you think of this circle? That's what I kind of think of, but it's tangent. Tangent is opposite over adjacent, or sine over cos, y over x, however you want to think of that. It's positive, so we're in quadrant 1. How do you end up with it equaling 1? Good, because anything over itself, bless you, will give you 1. So it's like this situation right here. So what's that angle? Pi over 4. And if you're in quadrant 1, that just is your answer, pi over 4. If you're in quadrant 1, that's how far you rotate. So that's it. All right, now this one is a little tricky because it's square root. Well, first of all, it's negative. So let's decide what quadrant we're in. What are the 2 quadrants that are options for arctangent? 1 and 4. 1 and 4. Since it's negative, it has to be quadrant 4. If it's positive, it'll be in 1. If it's negative, it's wherever the other option is. Square root of 3. You have to back that up a step. So off to the side here, I'm going to write square root of 3 equals something over something. Now here's the 2 options. It can either be square root of 3 over 2 over a half, or a half over square root of 3 over 2. Those are the only 2 choices. Which one of those is going to give us just square root of 3? The first one, right? Okay, it's going to have to be square root of 3 over 2 over a half. It has to be one or the other. So tangent is y over x. So square root of 3 over 2 goes here, a half goes here. Which one gets the negative? Perfect. Okay. If you're worried about getting that backwards, you only lose like half a point, right? It's one way or the other. You don't have a whole lot of options. So what is this angle? Across from the square root of 3 over 2, what's that angle? It is pi over 3. But remember, you're looking for the amount of rotation. And since we're in quadrant 4, how'd we get there? Because these quadrants don't exist. You can't rotate through quadrants 2 and 3. How could we get here without going through these quadrants? Backwards, good. So it is negative pi over 3. Secant inverse of -2. Which function is the reciprocal of secant? Because I kind of don't want to deal with secant. I'd rather deal with like sine or cosine. If we flip secant, what do we get? I thought I heard somebody say it there. Cosine, good. So I would write this as cosine inverse of -1/2. Do the reciprocal because that's easier. So what 2 quadrants can inverse cosine be in? 1 and what other one? 1 or 2. Since it's negative, it's going to have to be in quadrant 2. Again, if it's positive, if it's in 1, if it's negative, it's wherever the other option is. So where does the -1/2 go since it's cosine? X or Y? X, good. So -1/2. That means the other side is perfect. See, this is all coming back to us. And then that means that angle across from the 3 over 2, pi over 3. But that's not your answer because your answer is the amount of rotation. So how far did we rotate to get there? Good. Oh my gosh, you guys are awesome. 2 pi over 3. Perfect. Do you see what I was saying about how you have to be able to do it forwards to do it backwards though? Like you have to still know this. But we're just reversing that. All right, again, I would do the reciprocal. What is your reciprocal of cosecant? Sine. So I would write this as arc sine. Again, arc just means inverse. It's kind of like a fancy way of writing inverse. And what we're going to do is flip that over. You can go through all the steps of flipping that and then rationalizing it and canceling things out. But if you flip that, you're going to get square root of 3 over 2. Like that's what it's going to turn out to be. Do you see the 3's and the 2? Like it's what it's going to have to be. That's positive. So what quadrant are we in? 1. Good. If you're positive, you're in quadrant 1. So that's awesome. Sine is the y value. So that goes right here. And so what's that angle? Pi over 3. And so that is your answer because you're in quadrant 1. So that is the amount of rotation. If you're in quadrant 1, everything's nice. It's all positive, and whenever you get that angle, that's just your answer. All right, this one again is positive. So we're in quadrant 1. And square root of 3, again, you would write it like this. I'm not going to write this again because it's the same thing. This gets very repetitive. Do you remember me saying that? Like, does this feel repetitive? Then good. You're basically writing the same thing over and over again. The only difference is it's cotangent. Cotangent is x over y. So this time your square root of 3 over 2 is the x, and 1/2 is the y. So it was this over this, so x over y. So what is that angle? Across from a 1/2, what would you get? Pi over 6, and then that just is your answer. All right, these next ones look intimidating because there's two things at once. You just start with the inside and work your way out. It's an order of operations thing, okay? Also, this is not on the unit circle, like 3/2 and 5/13. If you don't see a 1/2 or a square root of 3 over 2 or a square root of 2 over 2, it's not on the unit circle, all right? So we're gonna use Pythagorean theorem. This is positive, so what quadrant are we in? 1, good. If it's positive, you're in quadrant 1, everything is good. Tangent is y over x, or opposite over adjacent. It's still SOHCAHTOA, however you want to think of that. So the 3 goes here, the 2 goes here, and you have to do Pythagorean theorem to get the other side, because again, it's not on the unit circle. So it's going to be 2 squared plus 3 squared equals c squared. So yeah, so 13, 4 plus 9 gives you 13, and then you have to square root it. So square root of 13. And then you're going to do sine of that angle. What this represents is that angle. Like if you want to call it theta, you can. But now we're going to do sine of that. Sine is what over what? I was going to say it, but I'll ask you guys. Sine would be what over what? Good, perfect. So it'll be 3 over square root of 13. And then you have to rationalize it. So 3 square root of 13 over 13. We've done stuff like that before. It looks intimidating because you have that little -1 in there. All right, cosine inverse of -5/13. What are the two quadrants cosine inverse can be in? 1 and 2. And since this is negative, it'll be 2. Cosine is what over what? Yeah, good. X over the adjacent over hypotenuse, or x over the hypotenuse, however you want to think of that. Here's your -5, here's your 13. Now you can do Pythagorean theorem for this if you want, but this is one of those triples. So if you know it, then we won't have to do that. 5 blank 13. No, okay, we'll have to do Pythagorean theorem. -5 squared plus a squared equals 13 squared. So that's 25 plus a squared equals. If you don't just know the answer, you got to be able to do this. You cheated. I saw you type it in your phone. Put that away. Put it away. Subtract the 25. What's that going to give us? Good, square root. Wouldn't it have been easier to just know that, guys? And then you're going to do tangent of that. This represents your angle, so we're going to do tangent of that. Tangent would be what over what? 12 over. There we go. It's SOHCAHTOA, guys, exactly like in geometry. You're staring at me like this is like Egyptian or something. Like, do we need to write out SOHCAHTOA off to the side, or do you guys know it? Opposite, adjacent, hypotenuse. I'm going to hand you a test. These ones have u in them. We're going to assume u is positive just for the sake of making this easy. If it's positive, what quadrant are we in? 1. Good. Draw a triangle in quadrant 1. And I would put the u over 1 because it has to be something over something else. So arctangent. Tangent is what over what? We're trying again. Opposite over adjacent. So u is the opposite, 1 is the adjacent. You have to do Pythagorean theorem to get the hypotenuse. We just don't know what u is. U is like a placeholder for a number, right? So it'll be 1 squared plus u squared equals c squared. 1 squared is just 1. And then to get c by itself, you would have to square root. So it is square root of 1 plus u squared. It's going to look like a mess because we don't know what u is. You just leave it alone. So this represents your angle. If you want to, you can call it theta. And then you're going to do sine of that. Sine is what over what? Opposite over hypotenuse. Good. So it's going to be u over this awful square root. And you do have to rationalize that, which looks funny, but I mean, don't overthink it. It's going to be u square root of all of that over all of that stuff. Again, we're going to assume u is positive just for ease of doing this. We're going to draw this in quadrant 1. And I'm going to put u over 1 because it has to be something over something else. So cosine is what over what? Good. So u is the adjacent, 1 is the hypotenuse. We're going to have to do Pythagorean theorem to get the other side. So a squared plus u squared equals 1 squared. I called it a. You can call it whatever you want. 1 squared is just 1, and then you'd have to subtract over the u squared. And then to get a by itself, you would square root that. So that represents your angle. You can call it theta if you want, and then we're going to do tangent of that. Tangent is opposite over adjacent, so it's going to be square root of 1 minus u squared over u. And thank goodness we don't have to rationalize. Now, I have one other thing I want to bring up, so I'm going to add a few extra problems on here. I'm going to call this first one 12b, because there are some shortcuts to some of these. I wish I'd printed it on there, but I didn't. So say it said cosine of cosine inverse, negative 5/13. I used the exact same problem as number 12 there. The only thing I changed is I changed that tangent to a cosine. So this picture wouldn't change. I'm not going to rewrite anything because this picture would be the exact same thing. Now we did tangent, so it was 5 over negative 12. But say you did cosine of this. What would cosine of this be? Yeah, negative 5 over 13. And do you see what happened there? Yeah, like it's cosine of cosine inverse. Like, would you really even need a triangle? I mean, you could draw one, but what happened there? Yeah, they just canceled out. Let me just show you because, well, there are some times that it works and sometimes it doesn't. I'm going to call this number 15 because we went through 14 on this paper. I'm just going to put a couple more on here so you can see how this works. So say you had sine inverse of 5/9. Just for the sake of being thorough, if I drew the picture for you, sine is opposite over hypotenuse. And then if you do the sine of that angle, it would be opposite over hypotenuse. It would just be 5/9. Like it's a no work kind of problem. But if the inverse function is the one on the outside, it doesn't work out like that. So let me show you that. Want to write this down with me? Do you want to write this down with me? Thanks. There are ones like this on your test. That's why I'm doing it. If the inverse function is the one on the outside, it gets a little bit more complicated because those are very restricted about what quadrants you can be in. So we're going to do this inside part first. Pretend this isn't even here. What quadrant is 7 pi over 6 in? It's exactly like these warm-up problems that I did for you. What quadrant is that going to be in? 3, good. What's the reference angle? Perfect. What goes across from that? A half, good. That means the other side, 3 over 2, good. And they're both negative, good. Sine is which one of those? The negative a half, okay? So this we found equals negative a half. So now what we've got is sine inverse of negative a half. What quadrant is that going to be in? Because sine inverse is very restricted. What are the two options for sine inverse? It's odd, so 1 or 4. Since it's negative, what quadrant is that going to be in? 4, good. Here's your -1/2. That angle across from it is pi/6, but that's not the answer. These quadrants don't exist. How did you get there if you can't go through these quadrants? Because what we want is the rotation. Backwards. So what's the final answer to the whole thing? -pi/6. So again, what I was getting at there, because I'm trying to save you work if you don't have to do any work. If it's sine of sine inverse of something, just cancel them out and that's the answer. But if the inverse function's the one on the outside, sometimes like you have to draw 2 triangles for that. You do the inside part and then the outside part. Is this making sense? Okay.